highlighting the difference between linear regression and multiple linear regression. For a minute, I may repeat this for the sake of significance of this. This is the formula for linear regression. Y is equal to ax plus b. So there are two variables here, x and y. X is called as independent, y is called as dependent. X is called as predictor, x is called as explanatory variable. Y is called as dependent variable, criteria variable, response variable. A and B are the coefficient constants. A is called as the intercept, B is called as the slope. This which we had already covered, and we had calculated this also together. We had calculated the linear regression for all of them. We had calculated the linear regression for all of them. We'll calculate once again also. We'll calculate once again also. Now what we are trying to say is, what is the difference between simple linear regression and multiple linear regression? Multiple linear regression has many independent variables. Multiple linear regression has many independent variables instead of only one independent variable, which is x. In linear regression, you have multiple x's, x1, x2, or xi1. The way it is represented here, see here, xi1, xi2, xi3, xi4, and so on and so forth. So each independent variable is associated with a slope coefficient, is associated with a slope coefficient. For that, again, remember the formula here. Where the slope is associated, the slope is associated here, this b, the slope is associated here, and a is your intercept. So like this is the significant difference between simple linear regression and multiple linear regression. Let us try to recollect all the discussions. Let us try to recollect all our discussions related to linear regression. Okay, so this was we had taken a case study of this. Now after that, let us look at what we have been doing here. Okay, so we had taken this data x and y, okay, and we had plotted this graph, and this is called as a regression line. This is called as a regression line, which is the best fitting line, which is the best fitting line. And these are the errors, because the points are not on the line, but they are nearer to the lines. So whatever the gap between the point and the line, that is called as the error. That is called as the error. Now, if you remember, using this x series and y series values, we had calculated mean, standard deviation, then correlation coefficient we had found out. After finding out the correlation coefficient, we had found out the slope and intercept. We had found out the slope and intercept. So the slope was b and the intercept was a. Uday, by any chance, do you remember this discussion, or you want me to do it once again? Uday? Uday, are you there? Uday, you want me to repeat this? Am I audible, Uday? Am I audible? Uday, there seems a network problem. Am I audible now?
Yes, sir. I mean, network issues with me, sir, I guess. Means I'm having like one or two mobile data I'm using. We don't have network.
Okay. So my request to you was, do you remember all this calculation, or you want me to do it again?
Yesterday's one I remember, sir.
You remember, na? For example, we can fastly do it together only. Okay. So the value range is of x is from 1 to 5. What is the mean of this? Mean of this is average of this. So 1 plus 2 plus, is the presentation mode on? Is the recording mode on? Yeah,
Yes, sir.
both are on, so we can use it. So for this x, how to find the mean value? Take the average of that. So 1 plus 2 3, 3 plus 3 6, 6 plus 4 10, 10 plus 5 15,
15,
15
3.
divided by 5. So mean of x is 3. Similarly, mean of y is, take the average of,
2.06.
yeah. So I can, or I can directly find out the formula also, of average, is it not?
Yes, sir.
I'll go in the statistical one. This is the average. See, 2.06 you got? Yes. Mean of y was 2.06. And do you remember how we calculated standard deviation of x and standard deviation of y? Before calculating this, what we calculated? We calculated the,
Variations.
excellent, very good, very good. So after calculating the variance of x and variance of y, how to calculate the standard deviation of x and y? Just find out the
Square
square
root.
root of the variance. So once we found out this standard deviation of x and standard deviation of y, so the correlation coefficient formula is this. Correlation coefficient formula is this: x minus x bar, y minus y bar multiplication auto sum of that, no, divided by the denominator part is square root of auto summation of x minus x bar whole square plus y minus y bar whole square. This we had calculated, as well as in Excel we had used this statistical function in Excel by name correlation. So it is here correlation function, is it not? It returns the correlation coefficient between two data sets. So either we can do manually, or we can do with the help of Excel, or with the help of R, or with the help of any tool like Veka and so on. So here we got the value of R as 0.628. Once we got the value of, now what are the values available to us, Uday? Mean of x, mean of y, standard deviation of x, standard deviation of y, correlation coefficient of between x and y. Once we found out that, we can find the slope. Slope is b. I am making it bold. Okay. Then intercept is a. I'll make it that also bold. So to remember this slope and intercept, again let us look at here. These are your slope and intercepts. Y is equal to a plus ax plus b, na? So this is what we were speaking about. Now coming here, how to find the slope and how to find the intercept? Just by looking at the formula, you tell me, Uday, you tell me the formula for slope, you tell me this formula for intercept. Slope is equal to,
R into S, Y divided by S.
what is R? R is this. R is correlation coefficient. What is SY?
First variable, sir.
That is standard deviation of Y. SY is
Okay.
standard deviation. How you calculate standard deviation? Square root of variance.
Yeah.
What is SX? SX is standard deviation of X.
Deviation of
How you
X.
calculated standard deviation of X?
Square root of
square root of variance of X. Now similarly, tell me the formula for intercept. It is written, just whatever is written,
mean
you have to.
of Y minus slope into mean of X.
Excellent. So what is the value of mean of Y? 2.06.
2.06.
What is the value of slope? Slope we just calculated, 0.425.
0.425. Yeah.
Excellent. What is the value of mean of X? 3.
3.
So now we calculated intercept of A. It means this Y is equal to AX plus B. Y is equal to AX plus B.
AX
We
plus
can
B.
represent, na? We can
Yes, sir.
represent this now. Y is equal to AX plus B. Now, once we do that, let us say, sorry. Now, what is the purpose of linear regression? Basically, the purpose of linear regression is a predicting the value of the dependent variable. Purpose of linear regression is predicting the value of future value of dependent variable. Now here, which is the dependent variable? You tell me. Which is the dependent variable? I am highlighting
Y
this.
is equal to X.
Y is the dependent variable.
Yes.
Which is the independent variable?
X.
X is the independent variable. Now we have all the values. We have the value of slope, we have the value of intercept. Let us say the value of new value of x is, let us say, 13. Okay. Now I have to predict the value of y. So I have to predict the value of y means I have to use this formula, y is equal to ax plus b. Now tell me what is the value of a?
0.785.
Excellent. 0.785 multiplied by what is the value of x?
13.
Excellent. Plus what is the value of b?
0.425.
Excellent. Tell me what we did now.
We find out y variables, new value.
Yeah. Only thing is this is I made it 133. It is 13 actually. So we found out the value of y. It means we have predicted the value of y. We have predicted the value of y with the help of this linear regression. With the help of this linear regression. I will show you now. I'll show this again using Excel tool now. Fastly you tell me what are the values of x and y. Fastly you tell me.
1 and 1.
X, all the values of x.
Like 1, 2, 3, 4, 5.
Excellent. Values of y.
1, 2, 1.3, 3.75, 2.25.
I just want to repeat. Mean of x, you tell me fastly.
3.
Mean of y.
2.06.
Standard deviation of x.
1.5, 11, 3,
Slope b.
0.425.
Intercept a.
0.785.
And correlation coefficient.
0.626832. 749.
Excellent. Excellent. Now what we are going to do is we are going to use Excel to do the same thing. Listen very carefully what I am doing now. I am going into data. This menu data. In the data I am going into data analysis. I am going to data analysis. Now what you are seeing here?
Regression.
It can do regression automatically. Hopefully, let us see how it does regression automatically. Okay. Now tell me. First, what it is asking, you have to just tell me what it is asking.
Input of y range.
Y range. Na? So we'll provide the Y range here. This is the Y range. Yeah. Now what it is asking?
X range.
X range. We'll provide the X range also. Now it contains labels. Yes. X is a label. Y is a label. Yeah. Now where your output you want to show. You want to show your output in the new worksheet. You want to show output in the new worksheet. So automatically whatever all this calculation we have done manually, whatever all this calculation we have done manually, Excel hopefully will do for us
automatically.
You remember this figure 0.62?
Yes, sir.
Let us check where it is. This 0.62.
Yes.
R.
Regression.
Excellent. This 0.425 and 0.785. Let us remember this 0.425 and 0.785. Are you getting it?
Yeah.
So we are just looking at the power of Excel. Okay, and it has given other things also. So many calculations which we need to learn. Like we need to learn what is ANOVA. Okay, you know the meaning of. You need to understand this term in ANOVA. DF, SS, MS, F, significance F. Here, see, I have done everything manually here. So we can, as we gradually learn and as we understand the need for this, we'll learn that also. Similarly, here we are seeing the intercept, okay, slope, then the error, then the t statistics, p values, lower, upper. So all these statistical things can be possible. Again, let us see what else we can do here along with regression. Let us say ANOVA correlation. If I want only correlation, okay, I can find that also. So I already have this range, new worksheet. See here, the correlation is 0.62683. Uday, are you there?
Yes, sir.
I lost my connection. Uh, did you, where I was, were you able to listen when I mentioned this? Or should I do it once again? I'll do it once again. Just
So your screen isn't visible.
okay, okay, I'll do that. Yeah, Uday, I'll show you once again. This last part I'll show once again. I'm going into data analysis. In data analysis, I am picking up this descriptive statistics. I'll say okay. It will ask for range. I'll give the range as this. Then I'll say labels in first row. Output should be in the new worksheet. And I am mentioning the summary statistics. So I'll say okay. See here, Uday, we are seeing the results now. Okay. Uh, Tell me now mean values. Uday, tell me the
3
mean.
and 3.06.
Are you able to remember these values?
Yes, sir. Y and X and Y.
3 and okay. So it means it has calculated everything. Mean, standard error, median, mode it is not there, standard deviation. You need to understand this also, but at a later. So range, minimum value, maximum value. The values are from 1 to 5, right?
Yes, sir.
The range is 5 minus 1, 4. Sum is 50. So all these descriptive statistics it is given. It is the beginning exploring R and Excel. It is never ending. The learning is never ending, and it's so powerful. It is so powerful. It is so easy to understand. so useful for your career.